Hello, everyone, and thank you very much for joining. Today, I'm going to have a quick chat with you about Docker. Just a warning before I start, if you've worked with Docker before, if you've done anything with containers, so this will be no new news to you. But if you feel left out the loop, this just might be enough to get you started. So to get to what containers is, I'm going to take a bit of a long way around and first talk about what containerization. And containerization is a method of virtualization where we virtualize the operating system instead of hardware as we usually do with virtual machines. Now, containers allow us to package up our application with all of its libraries and dependencies and everything that is really needed to let the program run. And this allows us to really quickly and reliably ship and deploy all of our software and our services. Containers are a very fast and lightweight alternative to virtual machines. I'll get into that a bit more just in a while, but before we can actually create a container, we must first create a container image. Now, the container image is an unchangeable file that contains all of the source code, libraries, things, and all that file that's needed to run the program. Now, once we have the image, an image is a static representation of the app as or service with all of its configurations inside. Once we get the image, we can then create a container. The reason for that is because a container is basically just a running image. Easy way to understand that is if we compare it to object-oriented programming, image is very much like a class, and then a container is very much like a object running from that class. To create an image, we have to first create a Docker file, but I'll get more to that when I get to the demo. Here's just a quick comparison between virtual machines and containers to see why containers are so much more lightweight and all around, in most use cases, better to use than virtual machines. And as you can see here on the left side, we have our virtual machine with the host operating system, our hypervisor running on top, and then we have 3 virtual machines, each of them running their own guest operating system and then the application on top of that. When it gets to containers, we don't have to install that guest operating system on top, which just makes it a lot more lightweight. Over here is just another comparison between virtual machines and containers. I'm not going to go through every point, but the takeaway here is just that containers is much more lightweight, easier to use, uses less memory, and is very faster than virtual machines. So the advantages of containers, firstly, it is platform independence. This is because it already contains all of the app data that it needs and all of the configuration. It is very resource efficient. It's very effective at isolating and sharing resources. It is much faster than virtual machines when it comes to deployment and quite frankly, every aspect of that. It's immensely good at scaling. It's easy to add and remove containers once you have an image, and it is just all around much simpler than virtual machines. So if you want to get started with Docker, I would recommend that you download Docker Desktop. You can also use Play with Docker, available at that URL you see there. However, if you do use Play with Docker, it only gives you a 4-hour session, so just be mindful of that when you play around. I would then also recommend that you create a Docker Hub account just to manage and store all of your images. So I'm going to do a quote unquote quick demo. Hopefully it's quick, but what I'm going to look at is first how to containerize an app, hosting it on a registry, running that app in the container, and then managing the container. So the app that I'm running is, I got it online off of Nigel Bolton's GitHub account. If you don't know who Nigel Bolton is and you want to learn more about all things Dockers and containers, I would really recommend that you go and check him out. So firstly, just here the localhost, you can see nothing running there. And then let's get to the Docker file. So a Docker file is basically build instructions for your image. It just tells Docker how to build your image and package it correctly. So if you go from the top here, the from is this is just our base image that is used. Afterwards, our label is just some metadata that's added. Here, a directory is created for the source code. All of the source code is copied into that directory, and that is made our working directory. And over here, our dependencies are being installed, and finally, the command is given to run app.js using Node. So now that that's out of the way, I can try and go through the demo. Just very quick. Okay. So the first thing we have to do is to actually create our image, and that, excuse me, that is as simple as saying Docker image build, and that's just the command used to build the image, and then we will give it the tag, and I'm going to use my Docker account, so that will be others, and let's give it a repo name, and this is the takeaway, so let's just say takeaways, and we give it the name of demo. Then at the end, we use the dot again. This just says all of the source code in the current directory is the source code that has to be packaged. And when I run that and hope, yeah, just give it a couple of seconds, and there our image is built. Now we can have a look and say Docker image list. And as you can see here, there's a lot of stuff, but over here, you can see the image created, and it is on our machine at the moment. So it was as simple as that. That is containerizing your application. Now, next, we are going to look at how to upload that application, and that is just as easy as saying Docker image push, and then once again, we just say, give it this information, and this will upload the image to Docker. I am, however, not going to do this right now. I promise it works. You can check me. It takes up to a minute or two, and I really don't want to waste your time any more than I have to. So I'll just leave that on the back burner, and yeah, trust me. Next, now that we have the image, we can actually create and run the container. And to do that, we can say the container this time and run. This time we give the extra details of saying we want to run it detached from a terminal, and we want to give it the name of demo. Then we also want to do the port mapping, and we want to put it on our side on port 8000. And then if we look on this side, in the app.js, we have it mapped to port 8080. So then I'm just mapping it to 8080 here. And then finally, once again, giving it a name. And once I've done that, as simple as that, we have created our container. Also, I should probably mention that you have to have Docker desktop running if you want this to work on your desktop. I forgot about that. But yeah, the container is now up and running. If we say Docker container list, here we see the container we just created. It's up and running. It's been for 23 seconds about now. And if we reload this, there you can see the app is working and running on your local machine. So yeah, that's honestly as easy as that. If you want to manage the container from here, you can just use the commands Docker container and whatever you want to do. So let's stop the container, and I just give it the name, and it's demo. And just give it a couple of awkward seconds, just around. Anymore now. There we go. Now we can use the list command again, and when we do that, we can see it is no longer there, but that is just because it is not running. It is still there, it still exists. So if we run that command again with the all tag, you can see it's there, but it's just exited. Now we can start up the container again. Docker container start demo, and it's up and running again. We just use on there, we can see it again. So final thing you can do with the management is you can also remove it inside. So to do that, we say Docker container, and we want to remove it, but before we can do that, we first have to stop it. So let's just stop the demo again. And yeah, there's that awkward silence again. Okay, cool. Just if we have a check here, refresh, you can see that this is not working. That is because the container is obviously stopped. And to remove it, we can say Docker container rm for remove, and we give it the name again, and it is removed. This time, if we use the list all command, you can see that it is totally gone and removed and no longer on our local machine. Okay, so that's that for the demo part, and I think I probably have more time left, so I'll just quickly touch on the subject of orchestration. So containers are obviously amazing, and if you're not using that, you should really think, why not? And to make it even better, you can also use orchestration. The most common orchestrator used is Kubernetes, and what orchestration does is it basically automates your scheduling, deploying, networking, scaling, health monitoring, quite frankly, everything. Orchestration is just awesome. You can give the orchestrator a desired state, and that orchestrator will ensure that that state is met at all times. So if a container is down, he will bring it up again. If you want a certain number of replicas, it will ensure that there is that amount of replicas up and running at all times, and it honestly just is the best. To just give you an example of how great these containers and stuff are, especially with orchestration, Netflix actually built some software. It's open source named Chaos Monkey, and what Chaos Monkey does, it just goes and kills random containers, and they are actually so sure with their containers and orchestration entire setup that they actually run this in development, just going around killing containers, and yeah, they're doing quite fine. So I think you can really trust it. Yeah, so that's all for me. I really hope that at least one or two of you learned something new. If not, then I hope it was at least not wrong.